As we already did twice this class, we are working on LDA. That is topic 1. LDA or NMF. This is like a technique. We're going to have to worry next week about sampling. I'm going to try to separate the sampling ideas from LDA because I think sampling is useful in itself. You should know how to sample things, whether it's for LDA or for other purposes. So we'll do a particular sampling that's a little disconnected to LDA. Our main application is LDA with sampling, but I would like to have an exercise in the homework about sampling just to get you guys going into sampling in general. What we're going to talk about today is summarization of text. And as a last addition, something that I think is useful for a lot of people to know and do, we're going to play a little bit with Elasticsearch. Indexing platform. Some of you may have used it already. Most of you, I'm sure, heard of it by now. I'm using this homework, next homework 5, as really a pretext for Elasticsearch. It's not like we really need it for any one of those things, but I think it's extremely, extremely useful tool for you guys to have and to know how to use. So I'm using this as a pretext for saying, how about you install Elasticsearch and we index those text documents that we worked with, and then we change the index to index the topics we obtained from LDA, and then makes the demo easier when you show it to DA. You can search by a topic and things like that. So if you took an information retrieval class, you very likely use Elasticsearch or some other very related tool. If not, this will take you about a day to install it and play with it and figure out how to work with it. It's extremely valuable tool to know how to use. That's pretty much is what's going to happen next. About the camera, I notice sometimes we don't have the right focus. So the focus must be on the board, not on me. I don't know if you do use this button. When you do the focus assist, so when you're playing with it, it's there. It's on the board. Okay.
So you want to focus off?
Yeah, I turned the autofocus off for this reason, because it starts focusing on me. I need the focus to be on the board.
Okay.
Right. So I usually you did something like you could select. I don't know why it's not coming up, but it's manual. I think this is the focus.
Okay.
Because the zoom is not going to change it, right?
No. Because I was just setting distance.
All right. Okay. So we already talked about those things. We're done with these. We're not done with this. We need to talk about more details about LDA. It's going to come next week with sampling as a package. So the idea in the first part is, like I said before, we have our documents. I'm going to say these are docs. And we would like to represent those documents that are typically doc versus words sort of representation. We would like to say from here, we want the document to be some sort of representation these are documents, these are the words. So there's a relationship here relationship here is more conceptual than before. We want a document to be a probability function or density of the topics, and we want the topics, a particular topic, to be density or probability of the words. That's the probabilistic model. This other NMF model is more algebraic. Right? So assuming we know how to do that, I'm going to come back to this next week. Assuming that's deal with for now. How can I do this? So everybody knows what summary means, right? I have a document. I'm talking about the English word summary, not the technical word. I have a document and I want to obtain a summary. What does that mean? You ever did that exercise in secondary school when you get some sort of piece to read, right? And the professor or instructor says, can you write a summary of it, right? So what did you do when you were asked that?
That's the information.
But how? You start reading the document, right? And then what did you write down? The most important things. But you kind of try to maintain the order. If you were to say three things, you probably maintain the order of these three things from the original thing. If that was a story about, I don't know, Genghis Khan going and raping and killing everybody in Asia, say. You start, first thing says, okay, Genghis Khan, like in 1200, he was the nephew of whoever, like some other Khan, right, in Asia, and then he started to get power, and then, I mean, you kind of follow the order of the original text. That's one thing. So summaries are so let's try to build together here. What do we mean by a summary of a document? It's another document, is a shorter document. What are the properties? So there's only important facts or maybe statements. What else? Tries to maintain order. If it says three things, it tries to maintain the three things, right? So tries to maintain what else? Significantly shorter. Typically, there is a parameter that has to do with length. You can, some things you can say, how big of a summary do you want? Did your teacher sometimes said, I want a one-page summary, I want a two-page summary, I want a half-a-page summary, no write more than 100 words? That's usually implies how big do you want it, right? What else do we want to happen in a summary? Is it enough to do this? Important facts, maintain the order, and figure out the length accordingly to some demand, one page.
Most of the information.
Right, so that doesn't miss any important stuff, right? So for factual summaries, if I describe Genghis Khan, this is probably okay, right? And in some sense, the best summaries that we have now are where? There's a website dedicated to summarizing things, very famous. Wikipedia, right? Wikipedia, that's what it does. Most pages are a summary, factual summary of Genghis Khan, of other famous people, events, battles, airplanes, whatever. There's like, how many? 5 million articles in Wikipedia in English. Every one of these articles is perhaps the most read summary of that thing, right? If you think of Genghis Khan, for example, or some other famous person, probably most people that heard and read something about that person, they read it from Wikipedia by now. Before Wikipedia, there are other, more like physical encyclopedia books and atlases and stuff like that. But now I think most people by default, when they try to read that, they read it in Wikipedia. So perhaps it's not obvious to you, Wikipedia is definitely a summary. I mean, let's talk about that for a second. Why is Wikipedia page about Genghis Khan a summary and not the, say, what's being summarized, right? If I have a summary, implicitly I'm saying something is being summarized. We can pull up the Wikipedia page from Genghis Khan if anybody doesn't know what I'm talking about. Why I say that's a summary? Definitely, that's not what's being summarized. In fact, what is being summarized on Wikipedia page about Genghis Khan? Everybody knows who Genghis Khan was?
No.
Okay. Very famous person. Anybody, hands up, anybody doesn't know who Genghis Khan is? Or was? No? Famous Mongol Khan in 1200 that from a little tribe conquered the whole Asia. And he started the Mongol Empire. Very brutal at that time. And after Genghis Khan finished his initial setting up of the empire, it was so brutal that people, it was a culture back then in Asia to not fight the Mongols. So after Genghis Khan, due to that culture of not fighting the Mongols, very few people like Chinese and Russians and others were even attempting to put up with the Mongols' rule because there were all those stories about their brutality. So as a result, the next Khans, the next 2 or 3 Khans, most famous is the Kublai Khan. How many people have heard of Kublai Khan? Do we have Chinese people who never heard of Kublai Khan? Because Kublai Khan is the one who founded Beijing. He's the one who put Beijing first and says, that's my capital here in China. And he is the Mongol emperor who conquered China and decided after a while that China's culture is better than Mongol's culture. So he said, you know what, we should convert to the Chinese culture because these guys are doing better than us. Anyway, so after Genghis Khan being so brutal, the next 2 Khans managed to have a relatively peaceful empire, and they run over all Asia, which is absurd at that time to run over all Asia. In the process, several interesting things happened. For example, the Mongols were so brutal towards the west that Russian capital had to be moved because it got razed by the Mongols. So the Moscow, we know Moscow, the city of Moscow, Russian capital, it was not in Moscow, but the original capital got so badly burned down that they had to move the capital north. That's why Moscow became the capital of Russia. Another interesting fact, they came so heavy, there is in Europe, there is something called the Black Sea. Every country got raped and wiped out, except the country that is right behind the Black Sea because the Mongols came this way. So my country, Romania, was not erased by the Mongols. That's why we still have a Latin language from the Latin Roman Empire. Everybody else got a Slavic language around because they got erased by the Mongols. Okay. Finally, Chinese broke the Mongols' rules because they invented the gunpowder. Gunpowder was the Achilles heel of Mongols. They were very good on horses, very good with swords, very good with bows. No way to find them, but the Chinese invented gunpowder. Very abruptly, the Mongol Empire disappeared, and the Chinese regained their country with gunpowder. Short history of the Mongol Empire. Genghis Khan. But they're equally famous people. If you are not from that part of the world, perhaps you heard of Augustus Caesar, the Roman emperor, or Roosevelt, the president who won World War II, right? This whole stuff applies to them too, okay? So why Wikipedia is a summary and not the real thing? What is the real thing? How is the Wikipedia article about Genghis Khan written? Who writes that? And how?
You can put different topics.
The information from various sources.
Who writes it?
People, anyone?
People, but some articles in Wikipedia, in fact, most of them famous, like Genghis Khan or Theodore Roosevelt or or Franklin Roosevelt I was mentioning earlier, are actually edited by Wikipedia editors now. It is true that everybody can contribute on Wikipedia and everybody contributes on most articles, but the kind of articles that are very well put together and very often read and often cited, makes sense to have some professional editors cleaning them up. Those people are not trying to hide information or to be politically biased, but they curate the information to make sure it's accurate and to make sure it's well written. Me and you maybe wanted to add something to some of Wikipedia articles, but we're not writing in a professional way, the way editors would put it down. Also, they are very well organized, those articles, into sections that by now everybody is familiar with. Okay. So where is this information coming from? Sources like what?
Textbooks.
Okay, where the textbooks come from?
Someone else.
So who, on this kind of article, Genghis Khan, what are the original sources? Who are the people who really are concerned about what happened, how it happened? Is that true? Is that false? Is that a legend? Somebody has to separate legends. Like, there's a legend that says 1 in 10 people on Earth has some DNA from Genghis Khan because he was very bad, right? But how do we verify that? That's a spectacular claim. Yet people have to go and figure out if that's true or not. Whose job is that? Historians, right? So a lot of things like that come from historians. But there's different kind of articles on Wikipedia that are not historically based, right? Stuff about New York City, if I go Boston, then I have an article about Boston. That's also a summary. Everything you see in Wikipedia, it's a summary. If you want to really learn more about Boston and deal with the very specific aspects like the I don't know, North area or the South area or some specific project, Wikipedia only have summaries about those things, right? So, okay, that's a summary. If we have non-factual things, the two examples that I have so far, Genghis Khan and Boston or New York, are very factual stuff. Where is it, what it is, what's the climate, how many people, a little bit of a history, da. This is very factual things. But if you go into economics type of things, or into business, or into politics, things are not very factual. There's a lot of subtle implications in there. This is the easy stuff in the summary. Things like locations, dates, facts, numbers. In other words, if you summarize a thing, what's the population of Boston? It will be easy to identify in a text and summarize it. But subtle things, like why some politician is corrupted, for example, that's much harder to capture in a summary. Okay, so how do we do this? Suppose if you are a human, you do what you did in a secondary school. When the teacher said summarize something, you read that thing. Typically, you give it a read first, right? It's hard to summarize things without reading the first document, the whole document first, because you don't know how important something is until you see what's coming next, right? But how can a computer do this? Suppose I'm asking you now we're not in secondary school anymore. Say, I give you a document, long one, an entire book maybe, about Genghis Khan. Say, I want a summary of it. Can you write a program that does that? Kind of try to mimic what you did in the secondary school with your brain. How would you do that? Take that brain thing and implement it as okay, I want to write it with a computer. Can you do what you did as a human with a computer, read the document, figure out the important facts, and write them down, right? That's pretty much what the summary is. So that is what we're trying to achieve here. How do we read the document, break it down into important facts, and write those facts, right? And that's one thing. The other thing I may want to do, I may want to summarize multiple documents, right? Before I move on into technical aspects, who needs a summary? I mean, Wikipedia writes them down. for an obvious purpose. Most people don't need more information that's on Wikipedia about Genghis Khan, about Boston, about other things, right? Most people, the information that's enough, everything I told you in the 2 minutes of the Mongol Empire, that's on Wikipedia already, right? That's part of the summary. So now, of course, there are people who need more than the Wikipedia summaries, right? Take, for example, the page Wikipedia has on diabetes. Most people would not know more than that page about diabetes, right? They might be concerned with themselves or with the general knowledge about diabetes, or maybe see a documentary and they want to learn more about diabetes. I would say 95% of people, I'm guessing 95, I'm not sure. I'm guessing 95% of the people would be happy with that Wikipedia summary. Who would not be happy with it? Who would need to know more about diabetes than the 95% of the people? Doctors, obviously. Who else?
Researchers, like if somebody is trying to find a cure or something,
Okay.
probably not a doctor. They're involved.
Even somebody sick of diabetes, if a doctor, go to the doctor says you have diabetes, you probably want to learn more, you get more interested in diabetes than the Wikipedia page and summary for everybody, right? So, in general, summaries are for people who don't want to delve too much into a topic. They just want to know the big picture. Okay, who was Genghis Khan roughly, what he did, and how the thing ended. There will be for every single topic more specialized people like doctors, right, or historians or mathematicians. The same thing happened with mathematics. A lot of Wikipedia articles now contain the main theorem and the main results in mathematics. And if you're not a mathematician, if you want to check out quickly the Pythagorean theorem, that's fine, you can check it out. Or if you never heard of, I don't know, topology in mathematics and you want to quickly know what that is, you probably check the Wikipedia page, right? But if you're a mathematician, you probably don't use Wikipedia too much for mathematics like you do day by day, right? This is valid in most cases. If you're not a lawyer, you probably look for a summary for some trial or for some evidence or for something happened, right? Especially now in the United States, everybody sues everybody. So it's quite a lot of interest into those trials and how it works. But if you are a lawyer or a judge, you probably don't rely on Wikipedia too much to do your job. So summaries are for people who are not specialists. This is applicable to everything. If you are a merchant, if you are a lawyer, if you are a professor, if you're a mathematician, if you're a doctor, any one of these people in their profession, they're specialists, carpenters, plumbers, whatever, they would not rely on a summary. They would do the actual historian notes or the pipe manual or the diabetes medicine school. But for the rest of the people who are not specialists, summaries are probably good enough to know what that thing is about. Okay, so how do we do this? There are two kinds of summaries. We're going to separate it here. Abstract. I think it's called abstractive or something like that. Generative. Sentence. Or extractive. Those are very, very different summaries. Summaries that work by abstractization or generative abstracts are somewhat related to the ones you did in secondary school. Because in secondary school, most people rephrased the documents. Even though we were kids and we were, 12 years old or so, we had the ability of abstractization. That is, reading a text, not have to copy paste what you see there. We saw there's a lot of talk about Genghis Khan's and battles and all that. Maybe somebody come up with an abstractization of that whole section that says there were important battles and they win it by having an advantage on horses. That will be an abstract because this particular piece of text, it's not in the documents I'm reading, right? I came up with it as an abstract notion of the 2-3 paragraphs or 7 pages that I've been reading. I'm reading about Genghis Khan battles, And every battle has a description and how it's been won and da da da. And I'm coming up with something that's not copy-paste from the document. I'm saying most of these battles include horses, and the horses were the main element of the Mongols. That, by the way, is true. A lot of the, what we call 6 centuries later, blitzkrieg, was invented by Genghis Khan with horses. It was so fast that before people figure out what's going on, the battle was over. That's what Hitler did later on with tanks. Okay? So abstract summaries are the ones that are not copy-paste, not from text, verbally, as opposed to those which are parts of the text. So if I look for sentence or extractive summaries, it means I'm going to select some piece of text that's in the original document and that somehow I evaluated as being extremely important or relevant or extremely significant or representative for the whole paragraph. Right? Do you understand this? So in an abstract summary, I have to come up with something new that is a synthesis, an essential description of what I'm reading, but it's not copied from that document. In a center of extractive summary, all I do is figure out what sentence of what unit of text is good for my summary. I have some scoring function there, and I decide, okay, this part goes in my summary, this part does not go in my summary. So this summary will be a subset or subsequence of the original text. Which one do you think it's harder for a computer? Yeah, this is mostly for who? Humans. And this is mostly for computers. This is one of the AI open problems. This is still something that differentiates, even today, after so much computation, so much AI, right? This is still a good differentiation between humans and computers. Humans will have relatively very little trouble coming up with an abstract summary. Even a secondary grade student, 12 years old, which is not the brightest student in the class, will have no trouble synthesizing a piece of text that's at his level. That's something that he can understand, right? But the computer will have a hard time with that. As opposed to this, which is much easier for computers. Once I figure out the units of text that I'm working with, words, bigrams, sentences, figure out which ones are important or relevant or significant, no problem for a computer. Humans will make some mistakes on this. They will have, it depends how big the text is that I need to summarize. So this is something that's still an open problem in AI. It's hard to, it's easy to differentiate a human from a computer that way. So this is what computers do mostly. And I'm gonna show you some stuff for how to do this, and then you guys are gonna have to implement it in your homework. Before we move on to starting my computer and the projector, what's the idea here? First of all, I have to do segmentation of text into text units. What is the standard text unit for syntactic or lexicographic meaning? No, for syntactic meaning. What is standard unit of text that we use as features? So for syntax or lexicographic, this is the word for unigram. For writing purposes, the basic text unit is the character. When you describe a language, for example, like Indian languages versus Russian languages versus Latin languages, you can immediately tell by the characters what's going on and how the language constructs work. In Chinese, characters have a different meaning than in Latin language. The words work differently, right? And for semantic purposes, semantic means meaning, right? When I try to understand what is it that this piece of text is trying to say, what's the unit that you understand what the text is saying?
Sentences.
The sentence. Right? So you should know this about text. That's why if I have very complicated, if I'm trying to do machine learning or a search, and I know the search is keyword based, which kind of units I need to match if I know I'm factually based on names, locations, dates, numbers. What units do I need to match? Words, keywords, right? Most web queries work by words, right? That's why a lot of the information retrieval techniques are based on unigrams or words. That's why machine learning, for a lot of what machine learning is good at, is based on word features. If I want to do a semantical meaning, then I know syntax won't help me that much. It's the meaning that I'm trying to get across that I need to go at the level of sentences. Semantical matching is another open problem in AI. We don't know how to do semantical matching. We can do about 50% accurate, which is much better than before. But web search is not a good example. Web search words by words. In fact, a lot of Google's queries that are semantic in nature will fail miserably. Google is not even trying to do semantical matching very well, because most of the queries they have, by now everybody puts keywords, nobody's trying to do semantic matching, so all their money comes from keyword matching. But if you are a lawyer and you ask a semantical question, what other cases with this that are like my current case are? That's a semantic type of search, and that's very hard. We don't know how to do that very well. It's still an open problem. We're slowly making improvement with a lot of very fancy, very, very fancy NLP. The kind of NLP that uses LSTMs, for example. That does make some improvements, but it's still way off compared to the keyword. Keyword search is a 99% accurate for most people, right? If you type a keyword like New York, concert, Rolling Stones or something, it will 99% of the time put you to that page where the concert is of Rolling Stones in New York, right? But for semantic searches, I don't know how many of you try that. You can try it in your favorite search engine. About 50% off. But that's what summaries are going to do. They're going to work on sentences. So to do this, I need first to find the text units. That's not a hard problem. Finding the words is an easy problem in English. Finding the sentences, it's also a relatively easy problem in English. How do I find sentences?
Some punctuations.
Usually by punctuation, end of line kind of things. So I'm not trying to understand the meaning of a sentence. I'm trying to figure out, okay, this is where that meaning ended and there's another one coming up. That would be hard. But rather, I'm trying to say whatever is a dot or a question mark or some break in text is probably the end of a sentence. And that's pretty accurate. And then I need a sentence, assuming sentence is my unit, score. As in how important that sentence is, right? Because what I'm going to end up doing is score those units and create my extractive summaries with the top, right? So rank by top, by score, and output top k units, that is sentences. So I want this top k to roughly correspond to the given length. Somebody says I did a page, I'm going to output sentences. I'm not going to go by top k, but I'm going to go until I kind of fill up a page, right? If somebody says really I want 10 sentences, then I'm going to put really the top sentence. But I usually go by this top, and I'm done when I fill up the length that I need. what's the danger with this?
The order.
Hmm?
The order.
Right, so this score doesn't play very well. Score, so the issue mentioned here is score versus order. Right? What I think he's implying is, what if I have a bunch of sentences with high scores that not are in the order that I want? What should I do? It's an easy fix. I could look first at the top K sentences, say, I score every one of them. I give the top K this, that, and that. I figure out they fill a page. And then put them in the order of the text, right? So this is easy. What's another issue, more interesting? I could have two sentences of very, very high score that are essentially same thing, right? That could happen. That's the same problem like machine learning has with features that are very, very correlated, but very good. So naively speaking, I can pick both features, but they're not going to do anything because one would be equivalent to the other. So that's the same thing happens in here, right? If I score sentences independently, maybe that something is repeated. That's a very important fact, and that's the last thing I want to do in a summary, to repeat a sentence. You can think of a summary as a very high real estate space. You don't want to use that space by adding redundancy to what you already have, right? So another issue is repetition or redundant. Two sentences have high score, but same content. Okay? In a more general sense, we need something for evaluation of a summary. And we want this to be a relatively independent tool. We want the evaluation technique of a summary, aka how good is it, to not depend on how it was produced. I want an evaluation tool that anybody gives me a summary, I can figure out if that summary is good or not. That way I can measure summaries from all over the place. I don't need to say, you have to necessarily produce it that way for me to measure it. So there is such a basic tool that is not very good, but it's so simple and became so popular, was developed very early, that I think most summarization papers are referencing it, an evaluation tool specific for summaries, again, because it was very early developed and because it's extremely simple. The name of it, the most popular tool, is called Rouge. It's a very simple thing, as mathematics. But to understand Rouge, you need to understand two concepts, which maybe we talked about it before, precision and recall. How many people know what those are as metrics evaluation for all kinds of data? So I'm going to take 5 minutes to talk about those things. Those kind of things that you have to know. It's kind of like naive Bayes. You have to know naive Bayes when you go for your data science interview. So what is precision and recall? We have two sets. One is the truth, or good, or judged, or relevant, or positive. It's kind of, that's the good stuff that's already known as good stuff. If you talk about patients sick of diabetes, those are the patients already known to have diabetes. If we talk about spam emails, those are the emails that we already know they're spam. They've been annotated, maybe annotated by humans. So this is the class that's the truth, the labels, we call it labels. This other stuff is the predicted by my system, by my algorithm, or inferred or retrieved this is the stuff that my system predicts as the spam emails, or as the sick patients, or as the documents I want to look at. And those are really the documents I want to look at, or the patients that are sick, or the emails that are spam. Right? So this is kind of the algorithm side, and this is the human side. The algorithm side. So of course, for an algorithm to be good, for any system to be good, those two sets have to be as close as possible, right? A lot of the machine learning, classification, and supervised retrieval systems, they're trying to match human perception of what's good or correct, right? You could say that correct adaptive. And here we can add high score, or probability, like whatever the system thinks is the best thing to do, right? I put all the names because in different data classes, you're going to see different names. In information retrieval, those are relevant documents, and those are retrieved documents. In machine learning, those are the annotated, labeled documents or images. This is what the system predicts, and so on and so forth. So how do we express the fact that we want those two sets to be close? There's two properties, precision and recall. One is how accurate this is, right? So let's call this set the algorithm set, and this is the correct set. I'm going to use those names, algorithm versus correct. Or maybe, should I call predictions maybe better? Or machine learning oriented? Predicted versus correct. So what's in here, in the middle? This is predicted intersect with correct. And if I take this intersection, prediction intersect with correct, and I divide it by the predicted side, this as a set, as a how many there are. This is saying how accurate my prediction is. How many of my predicted things are actually correct, right? That's what it's saying. Out of, you predicted 200 things, Google retrieves 200 documents. How many of them are correct? We call this precision. Out of the stuff that I'm outputting, I'm predicting how many of those are correct. If I divide this intersection here by the other side, I'm getting a different notion. So if I divide prediction intersect with correct divided by correct, this is saying what? Out of the objects that were truly sick patients or spam emails or images with some property, how many of them did you predict? Did you retrieve? Did you output? So I'm a lawyer, and I want to know all the instances of cases that have to do with drug dealers from Mexico. Sorry, no offense. It's in the news lately, right? So I want to do that. I'm a lawyer, and I'm working a case and say, I want all the previous cases in the last 20 years that have to do with Mexican drug dealers, right? The correct thing is all the cases that, records that exist about Mexican drug dealers, right? My system outputs a bunch of things. I use Google, or I use some intra search, whatever, and I get a bunch of documents. One thing is to say how many of documents are really about Mexican drug dealers. That's the precision. Another thing is to say, out of the set of documents about Mexican drug dealers, how many did you get? Right. So this we call recall. Now, what's the maximum for both of those? What's the maximum precision I can get? 1. This is between 1 and 0. And here it's also between 1 and 0 because this denominator being the intersection, the numerator being the intersection of denominator with something, it's always smaller than that something or equal. And when do I get both precision and recall 1? The two sets have to be identical, right? In other words, what is this stuff here? This part here hurts what? The stuff that I retrieved, but it's no good. What hurts? Which one of the measures is being hurt by this area here? I retrieve stuff that is not good. Precision. So this is going to lower precision. The more stuff is in here, I retrieve documents that are no good, or patients that do not have the disease, or emails that are not spam, my precision will go down. If I miss stuff, good stuff, these are the patients that are really sick, but I don't find them. My system doesn't return them. Meaning I'm going to hurt my recall. The more this area grows, the more my recall will go down. Now, can I get high precision but a low recall? I'm looking again at my plot. How would I get very high precision? Not have anything in here, right? If I don't have anything in here, I have a very high precision, right? Suppose this stuff is 0. What does that mean? Everything I return is good, but it's not that much, right? I'm still missing a lot of stuff. Suppose I have 1 million documents about Mexican drug dealers. How would I get a very high precision but a very low recall?
10 documents.
I return
10 documents.
only 10. They are about Mexican drug dealers, but I miss the other 990,900, all of them. So my precision will be 1 because all 10 documents are about what I'm looking for. But my recall will be 10 divided by 1 million. That will be essentially 0. How do I get a very high recall but a low precision? I don't want anything in here, right?
And every all documents.
I return everything. Everything means I include all the good ones. So if you look at predicted, intersected, correct, predicted is all of them. So how much is going to be predicted, intersected, correct? Would be correct, right? All correct ones. Divided by correct, recall is 1. But what happens with precision? I'm returning the 1 million documents about Mexican drug dealers, but that's because I'm returning all 300 billion documents on the web. So my precision now becomes 1 million divided by 300 billion. Okay? So Rouge does this, but it needs certain items. Rouge does not work like that. This is the mechanism that it employs. It's very simple, and if you take an information retrieval class, this is like day 1 of information retrieval. But Rouge doesn't work with documents or with images. It works with pieces that are relevant for my summary. So to evaluate Rouge, I need those two concepts, but I also need a gold human summary. Put that another name in here. I forgot about it. Gold. So when in machine learning, data science, people use the word gold, they means a ground truth. I forgot that name too. Ground truth. All those names mean the same. Ground truth, annotated, correct, labels, gold. That means a human, typically an expert. Like if it's diabetes, that means a doctor. If it's lawyer documents, it means a lawyer, and so on and so forth, right? A human expert have annotated these things and say, this guy is sick, that email spam, so on and so forth. And then Rouge will use a summary, a gold summary, that's already provided. So to use Rouge, the real difficulty is that to evaluate it, I need to have these gold summaries that some human produced first. And what Rouge does, takes the summary as a collection of words or bigrams or sentences and says, how can I evaluate the computer summary against the human summary? Well, it checks out to see if you got the words right or the bigrams right by those two notions, precision and recall. And if you get both of them right, you get a high Rouge score. And if you get some wrong, you get a lower Rouge score. There's another notion that I want to add up since I'm here, very important notion about precision recall. If I want to get some sort of average, like I want high precision, I want high recall, but I don't want to output two numbers. I want the score or the evaluation metric to be one number because that's nice, right? Most managers that don't understand mathematics, they can't deal with two numbers. You're going to get a boss that says, give me one number, please, okay? You have to produce a number. What's the right way to create a number out of those two things?
F-score.
F-score, which is? It's the harmonic mean between precision and recall, right? Harmonic means what? It's a type of average, like we have square average, arithmetic average, geometric average, harmonic average. What is the harmonic average of two numbers? Is their product, right? Two of their products divided by? Why we use a harmonic average instead of, say, an arithmetic? Wouldn't it be easier to just sum them up, divide by 2? When do we use harmonic averages versus arithmetic averages versus geometric averages versus quadratic averages? Anybody knows the quadratic average of two numbers? A squared plus B squared divided by 2, that's quadratic. Arithmetic is? Geometric is? AB, right? And harmonic is this one, 2AB divided by A plus B. Quadratic, arithmetic, geometric, harmonic. Why do we like harmonic so much? In here.
Reciprocal is that AB, like the numbers.
We want an average that's sensitive to small values. In other words, what's the problem with the arithmetic average? If one of the numbers is very big and the other one is very small, you still get a decent value, right? Suppose I take the precision recall. Those are like what? Those are like between 0 and 1, right? So suppose I have a very high precision, 1, and very low recall, 0. If I use the arithmetic average, what do I get? 0.5. Turns out 0.5 as an F1 score is not a bad score. I mean, it's not a good score, but it's an okay score. We don't want that because for precision recall, it's trivial to get one very high and the other one very low, like we just said, right? I can very simply make the recall 100% by retrieving all the documents. Google could very easily make the precision very high by retrieving only the obvious one document, and that's going to be relevant and not returning anything else. So in this case, precision recall, if you want one to be high, the other one to be low, it's easy. An arithmetic average is misleading because I take the average, I still get a decent value, and that's actually useless. What's happening with the arithmetic, the harmonic, how this harmonic thing reacts to small values? It's very sensitive to small values. If one of them is small, even if the other one is super big, this goes to 0, right? So harmonic mean more sensitive to small values. What about the quadratic mean? Sensitive to big values. If you want things to increase quickly, if one, that's typically we do the max, you know? People say, how do the students do in your class? And I want to show off. I want to say my students do very well. What kind of means should I use? Quadratic, because if I have one student that does very well and the other one's not so well, that's okay, right? Like I still get a high score. I can complicate this to put cubes. That's equivalent to the norms, the Euclidean norms, right? If the more I increase these coefficients, these 3, make it 4, 5, 6, the more I'm getting very sensitive to high values. So this is misleading if you say how good my students are. I use that average, and I only need 1 or 2 good students to appear that I'm doing extremely well. So what average should I use from a school perspective? How well are your students doing? harmonic will be a much more indicative of my teaching skills, because if harmonic is not close to 0, it means even the lowest students are still doing okay. If you compare to another class where the harmonic is low, it means there's some students that are doing very poorly, right? So be careful about this when you produce statistics on a result, especially for somebody who does not understand mathematics. You want to use the appropriate mean to do so. In here, like I said, we don't want to use an arithmetic mean because it's easy to get one very high and the other one very low. That's why people use the harmonic. So the F score or F1 score is this one. F1 refers to a coefficient that we can add into this formula to bias precision versus recall. If you want to be more towards precision versus recall, 1, it weights them the same. So that's why sometimes this is called an F1 score, because precision recall are weighted the same way. Okay. So that being said, let's see what those people do on summarization. So what we didn't quite decide yet is how much of this summarization you should implement yourself and how much should be come from a package. I think it's quite easy to implement it once you have the topic modeling, the LDA. But I didn't decide that just yet. Question?
Yeah, so the annotated corpus, would they just annotate the sentences, or what would the annotated corpus contain?
For Rouge, I need a summary. I need to say, here's a document, and here's the golden summary.
Okay, so that is extract.
There'll be a human that's a piece of text that says this is the golden summary. And then every computer system that produces a summary, it's evaluated against the golden summaries. That's for Rouge. There's other, like unsupervised methods that we don't need a summary, like measure, say, coherence. And they're not as good as Rouge in terms of practicality. It's better to have summaries that match human summaries, right? In terms
Humans
of
don't
action.
paraphrase it, right? It's just the copy paste.
Right, right. We're talking about extractive summaries. We're not, abstractive summaries are a different business. So this is a little bit in a research mode, as in we're going to look more at some papers here. But they're papers from a while ago, and if you read any modern papers, you'll see how much less involved are these papers. Let me start with this. Okay. So Rouge. Reference summary. That is gold summary or human summary. That's what I want to make. I don't have the document here. This is the summary of the document. And this is the system summary, right? So the basic version of Rouge will do what I just said on the board by taking, say, okay, this is the words that are good words, and this is the words that are produced. Ignore the count. I can compute some notion of precision and recall, right? Which are very simple things. Like recall, it says 6 by 6. Why is that? There were 6 words here, and I got all of them, right? And precision will be? I got all of them 6, but I think 6 by 7, right? Right, 6 by 7, because I have an extra word in my retrieve set. I think there's an extra word in there, was, or something like this. And here's another system that produces a different summary. I evaluate this system against the human summary, or the gold summary, or the label summary. The many names for this ground truth label that you have to match. Of course, this has a lower precision because there are more words in here. I still match all 6 words from the human summary, so I get recall 6 by 6, but precision is not that good because I have a lot more words in my summary now. I don't insist on those things for 2 reasons. Number one, I think it's very easy and you guys can figure this out in half an hour. Secondly, I think it's being taught in other classes a lot. So it's no need to, okay. So what happens if I get larger summaries like this one and I have bigrams in here? I can apply the same technology at the bigram level, right? My units now are not the words, are the bigrams. These are the bigrams from the reference summary. Those there are the bigrams for my summary. There's a little bit of a discussion. What does it mean to match a bigram? So we'll have to come up with a notion, well-defined, when bigrams match and when they don't match. But apart from that, which is an independent discussion, if things will match, I get so many matches, that will be the intersection divided by retrieved, that will be precision, divided by correct, that will be recall. So I can apply this notion for whatever units of text I have. If I want to apply it for words, I get it for words. So the little dots or objects in here are words, but I could apply it for sentences or bigrams or trigrams or whatever it is that I want to retrieve. Now, the only wrinkle in there is that if the unit is word, the matching is obvious, right? Either it's that word or it's not that word. But if it's a bigram, Virgil Pavlu, does that match Pavlu Virgil? Does that match Pavlu something Virgil? You have to decide what is a match, what is not a match. For sentences, this becomes more complicated. When are two sentences matching? Some people may say when they are verbatim identical. Some people may say, no, no, no. If they have an extra the, or an extra of, or an extra comma in them, it's still the same sentence. Some people may say, no, no, I can even allow one additional word like China in there, where some people disagree. Wait a minute, if you have additional word like China, that's a different sentence now. So matching a sentence, it's a much more debatable issue than matching words, right? So this is a simple version. There is other complicated version of Rouge. So I think there's several options. You want to match unigram, bigram, trigrams, that's called Rouge N. You want to match longest matches that, you know, kind of tries to capture sequencing that includes order. Do I capture that particular sequence in the original summary? For that sequence, people who take my algorithms class heard of LCS, maybe, right? Okay, so I want to capture the order of the words that was in the summary in my computer summary. And I can do it at the sentence level too. So the principle is the same, precision recall. The difference is what units am I applying this. And I will say for summarization, even today, even if this measure has been invented a long time ago, it's probably the most popular thing that most people would do unless they do research into summarization, so they play with those metrics. So if you go into text summarization, you can't avoid Rouge, even though I think it's probably around for 30 years or so. I'll show you another thing. We actually get into summarization yet. Kitchen here, we'll talk about that in a second. Oops, that's not what we want. We picked here a paper out of many, many papers that there are extremely many papers. This is a big subfield of NLP, but now they have their own conference. This summarization typically goes to something called document understanding, document knowledge conferences, things like that. So those are a subfield, text understanding, text knowledge, the subfield of NLP. And they even have their own data sets with provided summaries, like 2006 year, there's a summary, there's a collection of documents and a collection of summaries, like the golden summaries for those documents. So was a big deal. I think the last 10, 15 years, a lot of people have worked into this. Now it kind of slows down when the machine learning came up with LSTMs and those very fancy order tracking mechanisms for text. I think there's a lot of this that can be now done more automatically than before. But before LSTMs and when we have only like linear regression decision trees in automatic systems, this was a much bigger deal. So I pick again one out of the popular versions. You don't have to follow this one when you implement your summarization. What this is doing, it talks about Rouge and those documents. And then it's saying, what we want to do is to score each sentence, right? So as I explained, there's an initial phase of segmentation. Break the document I have into sentences, right? And then I have to score each sentence. This is a very simple score that I'm expecting you guys can implement very quickly. What it does, it says score of a sentence is what? Look at all the words in that sentence, divide by how many you have, that's an average. And this is kind of like some notion of how good that word is. D, I think, stands for a collection of documents, right? Collection of documents. So this is saying how representative that word is for my document. That is, if I summarize one document, maybe the document, if I summarize 10, maybe 10 documents. So how can I measure the importance of a word? I have to have those PD of W before I run the scoring. So what would be a reasonable notion of word's importance? TF-IDF or IDF alone, that's rarity. TF is like how often appears, right? So he just said 2 factors. I can combine a lot of notions into PD of W that has to do with how prevalent or how frequent the word is in my document, because if it's very frequent, it's an important word. And I should use something like IDF to avoid what? Stop words, like the will be the most frequent word, and I don't want to use the. So TF-IDF seems like a good notion to start with, but of course there's many ways to try to understand how interesting or how important the word is, right? I think this paper doesn't get into details of how to do that, because you can measure the word importance in advance. The paper is concerned about once you have this word importance, how do you score a sentence, which could be good for my summary if it has a high score, or not good for my summary if it has a low score. So I think this is some very trivial mechanism here. But the ones that they propose here is something based on the KL distance. If you remember the KL distance from last time, it's a distance between distributions. In trying to get KL distance to 0, it's saying what? I'm trying to have my 2 distributions as close as possible, right? So if you think of KL distance as a distance between distributions, again, 2 distributions over the same object are probabilities for each object. And if I try to, one of these distributions will be fixed, PD. That's kind of like the PD from above. That's fixed. That is what I'm trying to match. The other one, PS, relates to the summary I'm building up. So I would like to build a summary that little by little updates its PS distribution such that the goal is to get a PS distribution that matches PD. So in other words, think about it in a greedy fashion. I want to pick a sentence by I pick the first sentence. How should I pick the second sentence? I should pick the second sentence such that when I compute the overall distribution between of the 2 sentences, distribution perhaps over words, right? Every sentence will add some word counts. Word counts can be easily made in the distribution if I divide by the totals. This is fixed. This is already obtained from my document or from my collection of documents. So the reason I'm going to pick, the criteria for picking sentences here is that I want my word counts normalized to start matching this PD. So I'll do it greedily perhaps, because I don't want to run into massive optimization problems. I'll pick the sentence, first one that matches the best, but it's not going to be identical. I'll pick the second sentence that help the counts as much as possible to get close to PD. I'll pick the third sentence, again, when I compute the cumulative counts of all 3 sentences to try to match PD, and so on and so forth. At least that's the idea. To implement it, you have to read this and figure out what's going on. But once you have the KL distance implemented, take every sentence, add it to the sentences you have, recompute the counts, evaluate this scale distance, and you're gonna produce the sentence that is giving you the best the lowest scale distance here. And you keep going until you fill the size that you need. If you need 1 page, you keep going until you fill that page. And maybe at the end you resort them to have them in the order that the document wants. So they do these first, but then they say, okay, this would be much more interesting if we do it not with the original representation, aka words distribution, but if we do it with the topics that we obtain from topic modeling, like LDA. That's what you have to do. You have to implement a method like KL distance here. I'm not keen about that. If you want to use the simpler one, you can use the simpler one. But I'm really keen upon is not using the original words, but rather the topics that you get by LDA or NMF. Because topics are much more interesting things to match than words, right? If the topics are meaningful and I match the distribution over topics, I'm much more likely to end up with a better summary. That's the point of this paper, and they show that. There's a representation in terms of graphical models here, but their main point is, look, this is some reference output, this is a human output, and this is my final version after they tweak their algorithm output based on topic modeling. And they explain with Rouge, but also with analysis, aka looking at the summaries. Why is this summary, maybe it's a little longer than the other, but why is this summary better than these summaries? In particular, it's far more exact. Right? It contains much more factual information than this and that. Right? So what we want to get for the next homework is after we do topic extraction, which is a Python function LDA. It's not going to take you guys too long to call that and get topics. We want to implement something like this algorithm that uses those topics for summarization. And we want to summarize either one document. The TAs might ask you, can you summarize this particular document for me? Or 10 documents. Suppose I want to summarize all documents that are between January and March and are tagged as business. You know, 20 newsgroups has those tags, right, the labels. Suppose I want a summary of all documents between January 1st and February 28th that have the tag business. I'll have to do a search. I'll get all the documents between those 2 dates with tag business, and I have to do summarization. The only problem, the only wrinkle, is I could concatenate all these documents into one big document, but I run into trouble with the topics, right? Because remember when I do topic modeling, I get the topics as a function of the words and documents as a function of the topics, right? You guys follow me? What happens if I come up with a new document? In my case, I didn't really have a new document. I had 10 documents or 50 documents that I concatenate together. But somebody can say, I have a new document. I don't have a representation of that document in terms of topics, right? Because my topic modeling only produces topic representation for the documents that you start working with, say a training set. So can I obtain topic representation for a new document without redoing LDA? You know, I could add that document to the set, redo LDA, and now I've got everything in the topics. Can I use the topics I have? I'll move back here. Suppose I already have this. Documents are probably density over topics. Topics are probably density over words. Somebody shows, here's a new document. Can I get this? No. Represent that document as topics? Without redoing the whole machinery. I already have my topics. I'm going to put up another paper that's PhD level, but not now. So the problem in here, it's a little bit like training versus testing. This whole is a training machinery, gives me the LDA, gives me the topics in terms of words, gives me the documents I have, the training documents in terms of topic. How about the new document? Somebody comes up with a test document, says, can I get a probability density over topics? No. That would be a great exam question. How do you do that? Can you somehow use the existing topics to figure out what your document is about, the new one, in terms of those topics?
Can we find separately, can you find the topic separately for that talk and match it with the existing topics that we have?
I don't think that will work. I think technically that's possible, but I don't think that's what we want to get. I think we want to stick with the topics we already have and just figure out what's the probability of this new document for these already existing topics. We don't want to change the topics. How can I tell if one of these existing topics is very relevant for my document? What would it take to be very relevant?
All the words are associated with that topic.
All the high probability words from that topic occur frequently in my document. And how can I tell a topic is not related to my document? The high probability words from that topic, the what? Are not in my document. So we need a little bit of Bayesian probability, I think, like some very simple calculation to say, look, take any topic and compute the probability of that document being on that topic based on what words from that topic happen to occur and how often in that document. I think that's a very simple calculation. So that way we get the new document represented into topics. So we can do whatever we want to do with this representation. In my case, what I said, if I want to summarize 20 documents, I concatenate those documents. I run this procedure to get the topic representation, then I can do summarization based on these algorithms. So Kitchen will show you a little bit of this summarization now. And by next week, when we're done with TensorFlow, we'll all move into summarization and topic probabilistic realms. Oh, you need a projector, sorry. It's going to take a second to warm up. I'll put it on. Not successful. This is where yesterday, Monday, we had a problem with the thing there. We need to wait for this to cool off. By mistake, I turned it off.
So, I think, I can tell something about from perspective of NLP community. So in the NLP community, people focus on learning two types of summarization. So the extractive summarization and abstractive summarization. So for extractive summarization, usually we just extract some summary-worthy sentences or summary-worthy words from the original document. So the straightforward to do it is we can design a binary classifier. So for each sentence, we apply a binary classifier on the sentence, and we label it with summary-worthy or not. So we can extract some features from this sentence, but the problem of doing it is we don't consider the dependency between those sentences. Say if we already include one sentence in the summary, and we meet a new sentence which is very similar to the sentence we already put it in, then the classifier will also put it in. But then it lead to some like redundant information. So in the summary, you will see two sentences which are very similar. So you don't want to put them all in, both them in. So in this way, we want to use another method, like what Virgil taught in class. We extract a subset from the original document, and we minimize the KR divergence between the word distribution of this subset with a representative word distribution. So then we can consider the dependency between those sentences. And so and following what Virgil just mentioned, so I first run RDA on the 20 news corpus, and I got the RDA model, and then I want to perform a summarization on 10 documents. So I want to extract a summary from those 10 documents. So I concatenate those 10 documents first, and then run my RDA model on it. Then I got the topic distribution on those 10 documents, and then the topic word distribution.
So these documents are for 20 newsgroups?
Yes. So yeah, I believe this from I did. I extract 10 sentences. Oh no, 9 documents from the same category. And we have 2 summarizers here. So one is like what you just mentioned. We use the topic word distribution learned from LDA as the representative word distribution. I highlight the sentences extracted from this system in green, and in blue. And the yellow ones is I don't use the word distribution learned from LDA. I use the document word distribution. So this could be seen as a baseline. And the green ones are the overlap. So the green sentences are extracted from both these 2 systems. So if you go through those documents, we can see we have many green ones, green sentences, which means both 2 systems think this sentence is summary worthy. Here we can see, so when you do your homework, when you run your model on it, you need to train parameters. You need to select how many sentences you want to include in the summary. So as what you just taught, you can predefine the number of sentences you want to see in this summary. And also you can do greedy algorithm. You add sentences to the summary one by one, and until the care divergence stop decreasing. So when you say you add 1 new sentence in this summary, and the care divergence stop decreasing, then you stop. Then you don't need to predefine the number of sentences in the summary. So from the result, we can see, for example, the summarizer didn't extract any sentences from this document. If you read it, it's not relevant because all these documents are from the atheism, like they talk about God, Bible, but this document is not. And also we don't extract any like trivial sentences like this.
So what is the baseline model?
Sorry?
So you said there's 2 models, right? One is
Yes.
based on
So
is
one is in blue one, highlighted in blue. This from the RDA output from top. And the yellow ones is from the entire document word distribution. So remember, we want to minimize KL divergence between the summary, the word distribution in summary, and another distribution. So for this distribution, you can use RDA result output. You can use the entire document.
So that paper does that. First talks about the KL between the word distribution and the summary distribution. But then it says it'd be better to do it on topics rather than the original. That's I think Kitchen has here.
Yes. Because you assume the RDA model can learn some, especially those the top words, those top topic words. They are representative. They should be summary worthy. So you want to extract a subset which have the similar word distribution with those summary worthy words distribution. So yeah.
Okay. Do you have any evaluation? No.
I didn't, because we don't have ground truth.
Right. For 20 news groups, there's no human summary, so we cannot run Rouge, for example. but maybe we will have, my intention for the homework right now, which we're still cooking, is to have this data set that you already have, and one of these document understanding data sets for which there are summaries. So once you obtain your summary, you can run Rouge. Rouge, I think there's a script that you can download in Python or Perl and just run it. So you get some scoring. So let's recap this a little bit. What we're saying here is that if I use the topic modeling, what is the summary that I'm going to get?
Blue one.
And if I use the, what is green versus yellow?
Yellow is from document word distribution. Green is overlap.
Overlap between documents. Right? So these are the full documents printed here?
Yes. So I remove the foot and hip and head.
Right, the body of the
Only keep the
document.
body.
So how is this, looking at the summary, since we don't have a human summary, right, how can we evaluate it? We're going to have to look at it, right? So the blue one versus the rest in what's in this document. Unfortunately, those are not the factual documents that I was talking about here, right? When people start talking about God and religion and beliefs, it becomes very quickly very philosophical, right? So it's harder to summarize than if I take about those numbers and dates and locations and things like that. But let's try our best guess here. In a natural sense, it is not at all immoral to harm another species, as long as it doesn't adversely affect your own, I guess. You can disagree or agree with this statement, but how is it as a summary for that document?
Read the whole document. Really.
What?
Maybe you have to read the whole document.
Right, so document is here.
Okay, that's
Right?
right.
That's what I'm asking. Is that a good summary or not? I know this is harder for philosophical documents because if I talk about something more factual, it's easy to say, okay, do you include the main fact or not? Right? So how is it? Reasonable, good, bad, not so good, okay? Would you have found a better sentence or equally sized chunk that would be a better summary? Remember we talked about extractive summaries, so we're limited to what's part of the document. Maybe you can write down one yourself that's better, but that's not in play, so to speak. Good? Bad?
It doesn't make
Reasonable?
sense.
Not bad, at least, right?
It's actually good.
Let's find another one, another blue one. So for 20 news groups, you're gonna have to take, I don't know how you selected this document, by what criteria? How did you pick those documents?
Whether the top topic is dominant. Say if the probability of the top topic is larger than 0.5.
I see. I think that's a little bit of cheating because once you put a criteria based on the topics you have, then I think it's likely those topics will be good for evaluation.
Yeah,
but
but
suppose we pick some documents that are all about business, right? It makes sense to summarize them, maybe because
yeah, but I did add some noise here, like document 3 is not about the
I see.
idea. So we didn't select any sentences from it.
So that's why nothing, this is from 20 newsgroups? No.
Yes, yes.
Oh, okay, but it's nothing to do with this sentence, right? So I guess it was not picked up.
So for the noise, even yellow one is
What?
even yellow one.
Yeah, yes. Because because all other documents that talk about the God, Bible, and this, so the entire document word distribution should, like, you see the top word should be about, those
So entire you mean only these 9 documents? Or-
entire means all these 9 documents.
Okay, so not outside of this.
No.
How about this one? Is this a good summary of this document? Again, it's atheism really about homosexual sex? I mean, that's a philosophical debate, I guess. It's not a factual debate. These will be harder to evaluate than factual documents. So I'm hoping that this DUC collection that they used in the other papers, those are much more down to earth relative to summaries. So we're not going to ask you to do the yellow parts or the green parts, I think. We'll see. But we definitely want to create some summary based on LDA topics, which would imply that you have good LDA topics. So if the first part, aka LDA topic extraction, doesn't work, this won't work either. Right? Now, for this, I think you wrote your own code. Is that true?
Yes.
Right. So following that paper that I showed you, or some other paper, he put together a piece of code, I think in Java, that your TAs will translate into Python first by next week. So we have a Python version for it. You can use a package. We're going to allow you to use a package, but I think the code is not too bad. Can we see the code?
I had a doubt in documentary. I didn't understand why you not actually highlight anything in documentary.
Hold on. What?
What was the thing in documentary?
Documentary. Scroll up.
Why did you pick anything?
So again, why nothing got picked up from documentary? I think, again, philosophically speaking, we can disagree, right? This document is about a different kind of religion notion than the other documents. This, I think, is very specific.
Yeah, so when I pick this document, the top topic is different from all other documents. So based on RDA result.
So we're talking about summary, right? We're talking about what sentences do we select to output in summary. What would the sentence that should be selected in there? I mean, if you were to pick one, this reading once that biblical tribe known as Philistines still exists, I think this is not relevant for the other 9 documents. That's the main problem.
It's a treat the 9 documents combined together.
Yeah.
And pick the
So I think that's what happened here. He concatenated 9, 10 documents and said, give me a summary of this. And if it be just this document, obviously I'll get sentences from it. But this sentence is not related to the other 8, 9 documents. So that's why I didn't get picked. While the other ones have sentences that are somewhat related to all the other documents. So it makes sense to pick them as a summary.
Okay.
So here's a piece of Java code that, again, you can use we can use a library if you find one, but I think in this case it might be easier to follow that paper and implement something in Python or Java.
Yeah. Something like that.
So I think this follows the paper or some other paper?
Yeah, that.
Okay. So that's a little different than the homeworks we had so far, because this, unless you can find it online somehow, like a package that does it, summarization, you're going to have to write a piece of code for it. But by next week we'll have this in Python, I think, and TAs will help you out with it. I think that's it, right? Okay. Are we good? Okay. So next week we talk about sampling, and we'll have the homework up. I didn't, as a priority,